There we go. We're going to continue our work with fractions. Last week, we became masters of unit fractions, meaning we understand that a piece is one part of a whole. And we got down the habit of saying the names of those pieces: halves, thirds, fourths, sixths, and eighths. We realize most fractions have that weird sound at the end, THS. Okay, we're not going to call this fraction by numbers and say 1/8. 1/8 is telling me how to write 18. That is not a fraction. 1/8 tells me that you mean a part of something, okay? Today, we're going to continue to look at what happens when our numerator is bigger or greater than 1, okay? Here is your success criteria, and we will be working through these together by clicking the add response. For now, please listen to your success criteria.
Today we're going to be working on math learning target 3 and S3. It sounds like a lot, but it's actually quite simple.
I can barely hear it.
That you can understand a fraction.
I can barely hear it. Let's see if I can do something about that.
1 over b.
I don't think I can.
Quantity formed by one part when a whole is partitioned into b equal parts. Understand a fraction.
Sorry, I had to let Jalen in.
A over b as the quantity formed by the parts of size 1 over b.
I can hear.
Limited to 2, 3, 4, 6, and 8.
I can't hear it.
Okay, I don't know why you guys can't hear it, so let me go ahead and see if I can verbally narrate for you. Alrighty, so we are working on understanding when a fraction has a part greater than 1, okay? You will see that we have an example over here of 1/4. This letter B is showing that that's a number that we don't know. So before the picture was shown, we're figuring out that we don't know how many parts are on this. Then it's going to tell us that B equals 4, so we know to color 1/4. Okay? Then we move on to looking at the vocabulary, and again, another example. This we understand the two 1/4 unit fractions together gives us the fraction of 2/4. Okay? So taking a look at understanding that one piece is 1/4, so two pieces is 2 1/4 pieces, which we call 2/4. Okay? I think that was all of the examples before we started. Yep, just a reminder of the vocabulary that you should be using in your success criteria. I am still seeing people type things like, I know I was successful because I worked hard. This does not say anything about working hard. Nothing. This is about fractions. So when you are writing your statements, you should say something like, I know I was successful because I wrote numerators and denominators. Or this, I was not successful today. I need more practice because I did not create equal parts. Okay? That last slide is not a choice. It's not an option. It is an expectation, and it should have math vocabulary. I worked hard. It was easy. It was hard. I did it perfect is not math vocabulary. That's telling me that you worked hard, which I'm glad about, but it does not tell me you understand the words that we're learning. Okay, so make sure you come back to look at your vocabulary as you are completing that task. All right, kiddos, in activities, you are with me. Go ahead and go to your activities and look for the one up top titled 12-2 Fractions and Regions, Day 1. We're going to take a look at fractions and regions. Regions is a fancy name for some space, okay? It says review the success criteria done. Click on the add response. Complete the warm-up on slide 1. Complete slides 2 through 4 with your teacher. On your own, you will be completing slides 5 through 7. And on slide 8, you will be explaining with your vocabulary. how you know you were successful. This is in the directions. That means if you don't do it, I'm sending it back to you because you did not follow the directions. That means if you don't use vocabulary, I am sending it back to you because you did not follow the directions. Are we catching on yet? Okay, good. All right, go ahead and click that add response. Slide 1 is a warm-up that we will be working through. I'm going to give you a minute or two to complete that, and then I will show you the correct answers. Here is what the warm-up says. I'm going to get my highlighter ready so I can highlight some important information. All right. Pat made a garden in the shape of a rectangle. Hey, look at that. There's a rectangle right here. I bet that's on purpose. And divided it into 4 equal-sized parts. She planted flowers in 3 of the parts. Draw a picture of what Pat's garden might look like. All right, so you are going to divide this garden into 4 parts, and there will be flowers in 3 of the parts. I will give you a moment to complete your work, and then we will come back together and look at the answer. See, Levin, I almost missed your example. There we go. Levin, go ahead and show us the garden that you created with 4 equal parts, 3 of which have flowers in them. Boom, look at that. Look at those cute little flowers. They're so tiny. All right, Levin, tell us what you did. Here, I'll help. Unmute. There you go.
I'm sorry, I was on mute.
You're all good. All right, what do we do, Levin?
So I forgot to use the shape tool.
That's quite all right. You're getting better at it, so you're getting pretty good at making them even. But go ahead and tell us what you did.
So I did 3 in each square.
Okay.
3 dots representing. All right, you guys know what I'm about to say. 3 flowers.
Okay. So you just chose to put 3 flowers in there because the problem said that there were flowers in 3 of the parts. So I do notice that you have flowers in 3 of the 4 sections, and then you just chose to be extra and put 3 flowers in those parts. Is that right?
Yeah.
Beautiful. Thank you, sir. You can turn off your screen sharing. Aiden G, are you volunteering to share your screen?
Yes.
All right. Show us what you got, sir.
I'm trying to. Wait, wrong way. Oh. Miss Sousa.
Yes.
I'm not on like the computer. I'm on my phone doing Zoom.
Okay. Will you share your screen?
I don't know how to share my screen in. Like, oh, I figured it out.
Okay. There we go. Ooh, you made a different division. So Levin used a plus sign symbol. It looks like you kind of created a multiplication sign to create your parts as triangles. Interesting. And then I'm noticing you have flowers in all 4 parts. How many parts are supposed to have flowers?
So you're supposed to have 3 flowers. You're supposed to have 3 flowers in each, and you're supposed to have only 2 of them.
Okay, so Aiden, you have actually given us a great lesson. Take a look back at the word problem, everybody. She planted flowers in 3 of the parts. That does not say she planted 3 flowers in each. So take a look at my example. This has way more than 3 flowers. Do you see that? But this is correct. Why? Because there are flowers in 3 of the parts. Part 1, part 2, part 3 has flowers. Okay? So you did not need to put 3 flowers in each part. You needed to make sure that 3 of parts had flowers. Okay? That's a very important distinction, and it does come up with my 4th grade or my 3rd graders every year. A lot of people think this means I've got to create my garden and put 3 flowers in each one. 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3. And this right here would be wrong. Okay? This is incorrect because my directions say there are flowers in 3 of the parts. This has flowers in 4 of the parts. 1, 2, 3, and 4. Wrong. Okay? So we have to get out of our multiplication and division minds where we think about putting a number of items in the groups. Now we're just dealing with the total number of sections. Okay? We also saw people dividing in different ways. Terrence divided like, or not Terrence, Levin divided like this, which is perfect. Aiden G divided his rectangle into triangles, which is great. I divided my rectangle into long, skinny parts, which is also fine. As long as your parts are even, equally sized, you are good to go, okay? Make sure you put flowers in 3 of the parts. I don't care how many flowers it is. You can put 3 flowers in there, or you can do like I did and put a ton of flowers. You just got to have it in 3 parts, okay? William, a question.
Can I share mine?
Sure. Last one. Go ahead, bud. All right. Tell us what you did.
So I did like a plus sign and made 4 little rectangles, and I did dots in 3 of them.
Nice. And your dots are representing what?
Flowers.
Wonderful. And there are flowers in 3 of the parts. You have way more than 3 flowers, and that's okay because the problem does not tell us how many flowers. It just says where the flowers are. The flowers are in 3 parts. Lovely. Thank you, William. All righty. Let's go ahead and go on to slide 2. So make sure you have completed slide 1. Oops, I clicked on the wrong share. Let me change that. There we go. And again, your slide could look very different from what we saw as long as you have 4 parts and flowers in 3 of them. Okay. All righty. Slide 2 says watch the video and follow along. Here comes our video. Hopefully you'll be able to hear this better. And follow along. So let me go ahead and click the play button once this loads. There we go. Lovely. All righty, here we go.
We can't hear.
Nothing's playing yet. Ooh. Interesting. Okay, here we go. I will narrate again. Let me just go ahead and turn everything off. Okay. How can you show the names and parts of a region? We're naming and showing the parts. That is our goal. Mr. Peters served a part of a pan of enchilada casserole to a friend. What does each part of the whole pan of casserole represent? What part was served and what part is left? Those are our questions. In this problem, what is the whole? So tell me, guys. Let's go ahead and unmute. How many parts? 6. Very good. We are dealing with 6. Okay. The whole is the whole pan of the enchilada. Into how many parts was it cut? 6. What fraction is assigned to each part? What do we call one part of this?
It's 1/6.
1/6.
Good. 1/6. Mr. Peters cut the whole pan of casserole into 6 equal parts. The fraction 1/6 is assigned to each part because there are 6 equal parts. The whole casserole is divided into 6 equal parts. Each part is 1/6 of the whole. You can use fractions to represent more than one of the equal parts. 6 copies of 1/6 is 6 sixths. So the whole is 6 sixths. The unit fraction is 1/6. What part of the fraction tells the number of copies of the unit fraction? All right, help me out here, guys. If I want to say how many pieces, am I going to use the numerator or denominator? Notebook. Notebook. Whew.
Numerator.
Numerator.
Numerator is correct. That is our top number. So if you want to know how many pieces are going to be used, you will click on the numerator. Yay! The numerator is the number of copies of the unit fraction. 2 copies of 1/6 is 2 sixths. So 2 sixths of the casserole was served. That's why we can see there are 2 pieces gone, eaten, missing. Okay, 1 1/6, 2 1/6. We call this 2 sixths. 4 copies of 1/6 is 4 sixths. So 4 sixths of the casserole is left. That's why we have 1, 2, 3, 4. What part of the fraction stays the same and why? The denominators are the same because they show the total number of equal parts for the situation. So in our example where we were talking about what was missing, 2 sixths. How many are left? 4 sixths. So that denominator stays the same. Okay, there we go. Not bad for narration of a video that you can't hear. What? Okay, so this is an example page. As you are working independently on your work, if you feel stuck, you can come back here to see examples of how to answer the types of questions we are focusing on today about fractions and regions. Okay, what questions can I answer about that? Any questions about anything you saw in the video? Numerators, denominators, anything? Terrence.
It wasn't a question. It was to share my screen on 3rd page, but that was a long time ago.
Gotcha. Sorry, I missed you. Levin.
Are we doing breakout rooms?
Not right now.
Okay.
All righty. Let's go ahead and go to slide 3. Slide 3, it says, with the teacher, Mrs. Patel made a cake. What fraction of the whole cake does each piece represent? Each piece, okay? So they're trying to trick me here. They're showing me a cake that has some pieces missing and some pieces here, but that's not the question. Let's underline what's in the question. What fraction of the whole cake does each piece represent? Let's underline that. Each piece. And we're looking for a fraction. Well, in order to know what fraction I am going to show, I have to know my denominator, or how many parts are in the whole, okay? So I'm going to label or put a dot to count the pieces. I'm going to start here. 1, 2, 3, 4, 5, 6, 7, 8. There are 8 pieces on this cake. So that's going to be my denominator, my lower number.
1/8.
The question is, what fraction of the whole cake does each piece? That means one piece. So one piece, whether it's been eaten or still there, is 1/8. That is the fraction of a piece of this cake. Any questions on that? And again, I like to use this dot strategy so that I don't make a mistake. Sometimes if I'm counting in my head, I'll forget where I started. So this is a great way to help make sure that you don't miss a piece, okay? Let's look at number 3. It says in the picture on exercise 2, oh look, exercise 2. How many 1/8 pieces were eaten? What fraction of the whole cake was eaten? So there are 2 questions here. I'm going to highlight them in different colors. The first one is how many 1/8 pieces were eaten? The second one is what fraction of the whole cake was eaten? Okay, so let's answer these questions. This first question is where we usually see mistakes. How many 1/8 pieces were eaten? Third graders tend to get really excited about fractions and think that they need to write one, and they don't. How many 1/8 pieces were eaten? I can see there are 2 pieces missing. 1, 2. So that's what I will write. 2 pieces were eaten. And I'm going to type that because it's a lot faster for me. 2 pieces were eaten. This question did not ask me for a fraction. It just says how many pieces were eaten. And when I look at that picture, I can see that there's 2. So there are 2 parts to the answer inside of this problem. The first one is how many pieces were eaten. The answer is 2. So that's our yellow question answered. If I were to stop right there, I would be getting half of my credit, which is a 50% F, because there are 2 questions here and I've only answered 1. So make sure when you see 2 questions, you answer both. Don't get so excited and just move on. Second question, I'm going to change to pink so we can see that it goes with the pink question. What fraction, now we need a fraction, of the whole cake was eaten? Well, again, there are 2 pieces missing and there were 8 pieces on the whole cake. So 2/8 was eaten. And again, if I'm writing, you're writing. So now I have answered both parts of my question. How many 1/8 pieces were eaten? 2 pieces. What fraction of the whole cake was eaten? 2/8. You'll notice that this number is the same. My numerator is the same as the number of pieces that were eaten because all we're doing is taking pieces and representing it as a fraction. That is a pattern that we are wanting you to notice. Okay, the top number, the numerator in a fraction, describes the number of pieces being discussed in a problem. Any questions on that one? Okay, feeling good? Alrighty. Let's go on to slide 4. This is the last one that we will be completing with the teacher, and I don't want us to break out for this one. I want us to talk through it. How many 1/3 parts are blue? Again, this is asking me about parts. How many 1/3 parts are blue? When I look at this model, I can see that there are 1, 2, 3 parts. 2 of them are blue. So how many 1/3 parts are blue? 2 parts are blue. So go ahead and write down that answer, that 2 parts are blue. Again, this doesn't ask me for a fraction. It asks me for the number of parts. Angie?
Can you go back up to the top? I mean, at page 3.
Sure. There you go.
2 pieces were eaten. Okay, I'm about to type that.
All right, sounds good. 2 pieces were eaten. Okay. The next question does ask for a fraction. What fraction of the whole is blue? Well, now we've got to look at the whole. There are 3 parts. So my denominator is going to be a 3. We've already counted that there are 1, 2, 3 parts. 2 are blue, 1 is yellow. What fraction of the whole is blue? 2/3 are blue. 2/3 are blue. Blue. There we go. Make sure you have labels, because remember, if you don't have labels, I'm going to assume you are talking about purple unicorns flying through space. And if you are giving me 2/3 of a purple unicorn flying through space, I'm going to call you a unicorn murderer and ask you lots of serious questions. So make sure you put the label so that I know what parts you are talking about, okay? Last question. What fraction names all of the parts in a whole? What fraction names all of the parts in a whole? If I were to have all of these parts, I would have 3/3. 3/3 is all of the parts in the whole. So 3/3 is all of the parts of the whole. And that was a lot. I'm going to leave that out there for you guys to see as I talk through this. Okay. When you are working with a whole, that is when you have the same numerator and same denominator in number form. Okay. All of the parts is having the total number present. In this example, the total number present is 3. So this would be 3/3. Remember that fraction word is very important. If you were to tell me 3 3s names all of the fraction, I would think that you were talking about three shots that you took for 3 points each on basketball. Okay? That's not going to help you. I'm going to think you were talking about 3 3-pointers. You're not. You're talking about thirds, which are parts. So we have to say the fraction word, 3/3. Okay? A lot of 3rd graders look at these and call it 2 3s or 3 3s. And again, I'm going to think you're talking about 3-pointers. Okay? Those fraction words are important because they are a clue or a signal that you are talking about a part of a shape, not a whole shape. Okay? So make sure you use that fraction word as you are reading these fractions. Okay? You are getting ready to do what the directions said. The directions ask you to solve 5, 6, and 7, and then to complete your success criteria on slide 8. Remember, on your success criteria on slide 8, it is not a choice. If you do not do that slide, I am going to send it back to you with a message that says you didn't do this slide. This is helping me grade your awareness of vocabulary. I can't grade your vocabulary if you don't turn vocabulary in. Okay? So make sure on slide 8, you are using math vocabulary. You are not saying things like, it was easy, or I got done fast, or I worked really hard. That's not math vocabulary, okay? Math, 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 vocab, 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 okay? 11, a question, Bebe.
And if you don't do your success criteria, you're a purple unicorn flying through space murderer.
That would be if you had a chopped up unicorn. Yes, I would be very sad about that. William.
On slide 7, what does it mean by what fractions have you shaded?
So on slide 7, it tells you to draw a model. It says draw a circle. And then it tells you how you're going to shade. You're going to shade more than 3/6, but less than 5/6. So this will be based on the model that you draw. Okay. And shade, so if this were a piece right here, I would color or shade it like this. Okay. Does that answer your question, or is that still confusing?
I got it.
Got it. All right. Terrence, a question.
I never had a question.
Your hand was up.
Oh.
11.
Are we going to have office hours?
Remember, today for office hours, I have to do testing. So I will have like the last 15 minutes of office hours. You can hop on there if you need me, but the majority of it, I will be doing testing. If you feel like you need help on this assignment, you can come in the last 15 minutes, or you can tell me tomorrow morning and we can set up a special time for you to be able to get some help. Okay?
Okay.
All right. Okay, kiddos, I'm going to go ahead and stop the recording. Please hang out so we can talk about your schedule.